Today we're going to be taking notes on simplifying algebraic expressions, substitution, and absolute value. So let's go ahead and start with simplifying algebraic expressions. When you see negative 5 plus x plus 2x minus 3x plus 4, what we want to do is we want to combine our like terms. That's the key thing in simplifying this expression. We cannot solve this expression. There is no equal sign at the end, and there is no number or value after the equal sign. Our goal here is not to solve, but it's just to simplify, to go ahead and combine the like terms, and like terms are terms that have the exact same variable. Okay? Each of these, this is a term, this is a term, this is a term, this is a term, and this is a term. Terms are basically in between our addition and subtraction signs. So those are all of our terms, and what we want to do are combine the ones that are alike. Well, there's a couple of ways that we can do this. Let's go ahead and start out basic. First of all, I see that I have a negative 5, I have a positive 4, I have a positive x, a positive 2x, and a negative 3x. Well, I want to go ahead and represent those using my chips. My yellow chips are going to be positive. My red chips are going to be negative. Now, my larger yellow chips, those are going to represent x. Okay, all the larger ones are my x's. The smaller ones, again, positive and negative, those are going to go ahead and just represent my numbers, or the value of the numbers. So if I want to go ahead and represent this using my chips, I have negative 5. So I'm going to put 5 negatives. 1, 2, 3, 4, and 5. 5 negatives. Okay. I also see, so I've taken care of that. I also see that I have 4 positives. So I'm going to go ahead and represent those as well. It's okay that I'm going out of order. That doesn't matter. 1, 2, 3, and 4. Okay, so there I've taken care of just my regular terms that have no variable attached to them. So negative 5 and positive 4 are done. Now I want to go ahead and represent my x's. So here I have one positive x. Oops, I have my pen in my hand, excuse me. Here I have one positive x. So that one is done. I have 2 additional positive x's. 1, 2. If I was to combine those together right now, I could call that 3x. And then I have negative 3x, so there's 1, 2, 3. Now what we have here is what we call zero pair. Zero pair is a positive, one red and one yellow totally cancel each other out. So anytime I see zero pair, I can go ahead and pull those out. So I have one red and one yellow here. That guy's gone. That guy's gone. A red and yellow here. That guy's gone. That guy's gone. Because zero pair are what they are, 0. That red one's gone. This yellow one's gone. This red one's gone. This yellow one's gone. And I'm left with one negative. There's nothing to match up with it, so it's just going away. Again, my x's, they have 0 pair. This yellow with this red, and this yellow, and this yellow, and this red. And so my answer ends up just being -1. So let's go ahead and look at this a little bit more algebraically. If you're comfortable with the chips, then you can continue with that. But looking at this algebraically, what I can do is I identify it. I say -5 plus 4. -5 plus 4 is -1. I have x plus 2x. That makes 3x. X plus, I'll move my -1 down. 2x plus 2x is 3x minus 3x. Those cancel each other out. Again, I'm left with -1. So let's go ahead and look at a couple of problems in practice. First thing I want to do in this next one, -9g plus 2 minus 7h plus 5 plus g minus h, is first thing I'm going to do is I'm going to identify my like terms. Sometimes we want to rewrite it, or sometimes in this case, I'm just going to go ahead and start with the first thing I have here, -9g, and I have a positive g. I don't see anything else with a g in the expression, so there's nothing else. So those guys just get combined. -9 and +1, it's understood that that's a 1g. So -9 plus 1 gives me -8g. Then I have, I'm going to look at my next one, and I have +2 and +5. 2 plus 5 is just plain and simply +7. Finally, you see how I'm keeping the negative symbol or the minus symbol in front of that 7h, because we need to understand that -7h and -7h are the exact same thing. So I have -7h and -h. Again, -h is like saying -1h. So -7 plus -1 is going to be -8h. Now, we want to go ahead, algebraically, we want to go ahead and rewrite this a little bit differently. The first thing I'm going to do, well, we can go ahead and just leave it that way right now. Let's go ahead and move on to some other ones here. I have -8q, +5q, -8 plus +5 gives me -3q, +6, -3, 6 minus 3 is 3. R plus R plus R plus R plus R, that's 1, 2, 3, 4, 5. All that is 5R. That's it. Now this next one, I like this because we have F and G, we have G, and we have F. Now, this FG, -3FG, the only thing that can be combined with it is -FG. Remember, that's -1FG. That's the only thing it can be combined with. Even though this 2G and there's a F, those guys can't combine with the term FG that has the exact same variable. Okay, these aren't exact. So -3 plus -1 is going to give us -4FG. And then I have just plain F. It doesn't look like that can be combined with anything in the expression. So plus F, that's a positive F. There's no negative symbol in front of it. The G is all by itself, so we'll say plus 2G. And then the last thing I have to combine is just the 1 minus -55. So we end up with -54. Now, we want to go ahead. If you're good with that, great. And if you need to repeat this, go ahead. Again, you can use the chips if it helps you. We're going to move forward, though, and we're going to distribute. To distribute, I'm going to simplify this expression. The first thing I need to do is distribute. So I'm going to rewrite the problem over here. 2a minus 5 times the quantity a plus 1. Before we can simplify, though, we have to distribute. So I'm going to say 5 times a and 5 times 1. So I end up with 2a minus 5a plus 5. Don't forget to distribute that 5 to the 1. And I'll be honest with you, I just messed up. And let me show you why. I'm going to rewrite this. 2a minus 5 times the quantity a plus 1. What I did incorrectly is I didn't distribute negative 5 to the a and to the 1. I have to distribute that negative 5 to the a and to the 1. So I would rewrite it as 2a. Negative 5 times a is negative 5a. And negative 5 times 1 would be negative 5. Now I know there's a plus sign. If I wrote plus negative 5, that's fine, but it's still the same thing. Negative 5 is the same as minus 5 is the same as plus negative 5. So now I can combine my like terms of 2 minus 5, which is negative 3a minus 5. All right, let's go ahead and practice a few down here. So the first thing I'm going to do is I'm going to distribute. Again, I've got to distribute that negative 2. So I have b minus 2 times the quantity b minus 2. I'm distributing negative 2 to everything inside of the parentheses. So I end up with b minus 2b. Negative times a negative is a positive, so plus 4. So I end up with negative b, because this guy's positive, so that's 1 minus 2 is negative 1b, plus 4. Next, I have negative 5 times the quantity c plus d minus 4 plus 5 minus CD. So I'm going to distribute my negative 5. Negative 5C plus, minus 5D. So again, I distributed negative 5 to C and negative 5 to D. And then I just rewrite minus 4 plus 5 minus CD. Well, if I look at this expression, there's absolutely nothing I can combine together except for negative 4 and 5. So I can rewrite this expression as negative 5C minus 5D plus 1 minus CD. And that's it. Go ahead and try the next two on your own, and we'll look at them in class tomorrow. Now, on the back here, I'm asking you to go ahead and substitute values in. Again, I'm going to do number 4 for you, and then I'm going to ask for you to practice the next two on your own so we can look at them in class tomorrow. I have, for number 4, I need to substitute these values in. So I end up with 4 times negative 4. See, I'm not making it a 44. Some people think that, but that's not what I'm doing. Minus 2 times 2 plus 3 times 6. I just put the second value in parentheses to indicate multiplication. So 4 times negative 4 is negative 16, minus 2 times 2, which is 4, plus 3 times 6, which is 18. If I go ahead and I combine those like terms, I believe I end up with an answer of 2. Go ahead and try 5 and 6 on your own. Now, before you can do 5, though, we need to talk about absolute value. The absolute value of a number is the distance that value is from 0. The distance the number is from 0 on the number line. So going left or right, the distance 9 is from 0 on the number line is 9 places. The distance 12 is from 0 on the number line is 12 places. Then I have the absolute value of C minus D. Absolute value bars. You have to do the math inside of the absolute value bars. Absolute value bars are like grouping symbols. So really there's nothing we can do here because we don't know what C and D are. What if we did though? What if we said C equals 3 and D equals 5? Then we can go ahead and solve this and figure out the absolute value. So I would say the negative absolute value of 3 minus 5. Again, absolute value bars are just like grouping symbols. So I have to do the math in here before I can determine the distance the value is from 0. 3 minus 5 is negative 2. So we know that the distance negative 2 from 0 is 2, but I still have this negative symbol right here. So what I'm going to do is I'm going to say, okay, I know that the absolute value of negative 2 is 2, but because that negative symbol was outside of the absolute value bars, it's going to be negative 2. If you have any questions or anything to reflect on, please write it at the bottom of this page. Thank you.